The modern periodic table has a precise position for every one of the elements that have been discovered. In general, metals are found on the left and non-metals on the right. Elements with similar properties are placed in the same column, and each column is called a group. However, when first discovered, the periodic table was arranged differently. It was in 1869 that Dmitri Mendeleev, a brilliant Russian chemist and passionate card player, first constructed a periodic table of the elements. He had been thinking, could there be any connection between the recently standardized atomic mass of each element and its known chemical properties? Mendeleev wrote the element symbol on a card for each of the then known 63 elements, along with its atomic mass number. He then began arranging them something like a crossword puzzle. A horizontal row contained the elements with similar properties, while elements in the vertical columns from top to bottom were arranged in order of their increasing atomic mass number, and finally a pattern emerged. Mendeleev was so convinced his pattern was correct that he left spaces for elements yet to be discovered, and that was his stroke of genius. He even predicted the atomic mass and the properties of the unknown elements based on their vertical and horizontal position in his table. If the table really could predict the existence and properties of yet unknown elements, then other scientists would have to agree that Mendeleev's ideas were right. And 6 years later, where Mendeleev had predicted an element with an atomic mass of 68, gallium was discovered with nearly the same atomic mass of 70. This happened again with an element predicted to have an atomic mass of 70, and the discovered element, germanium, at 73. Then the predicted element with an atomic mass of 45, and the discovered element, scandium, with an identical atomic mass of 45. And all these new elements had similar properties to the existing elements in their same row. From then on, Mendeleev's table was accepted by scientists. Since then, the internal structure of atoms has been discovered. Take lithium. We now know that in an element's nucleus, atomic mass equals the number of protons, seen as gold, plus the number of neutrons, seen as gray, which here totals 7. So lithium's atomic mass, as seen in the upper left, is 7. Also, each element is now given an atomic number based just on the number of protons in its nucleus, which here is 3 for lithium. 1 proton more or 1 proton less creates a different element. So lithium's atomic number, as seen lower left, is 3. Because of these new discoveries, Mendeleev's original periodic table has been considerably rearranged. As you now read along the rows from left to right, each succeeding element's atomic number will increase by exactly 1. And it's the vertical columns that now group together those elements with similar properties. About 60 elements were known to Mendeleev. Today we know of more than 100, each with its own place in the periodic table. The elements are now written left to right in order of increasing atomic number. And the position of each element in this table describes exactly what its atomic structure and its properties are.